Welcome to Building Open Pipelines with Snowflake. I'm really excited about this session to walk you through new features in Snowflake that enable building truly open pipelines. My name is Jeremiah Hansen, and I'm an architect on our field CTO team focused on data engineering and data lake workloads. Let's just jump right to the end uh, and kind of give you the spoiler for this session. We're going to cover a number of awesome features in Snowflake for building open pipelines, beginning with Openflow to ingest data from our sources into a raw zone, dbt projects with workspaces to transform the data. We're going to store the data in Iceberg with Open Catalog, and then we're going to query that data from Snowflake and a couple flavors of Spark. Pretty exciting. What I want to do before the demo is actually just run through, give a quick overview, some data thoughts around data pipelines, and then we'll look at each of those features briefly. So we'll go through the ones I mentioned there and then actually get into a demo and show this all in action. And I even got a little bonus at the end around DevOps, which I'll show you. So just to set the stage, Snowflake is for data engineering, Snowflake's a mature enterprise platform. We support a lot of ways to do data engineering with Snowflake. Today, we're going to focus on those open pipeline components. So Openflow, dbt projects, and Iceberg. But just want to put it in a larger context that Snowflake supports a lot of different ways to do data engineering, um, depending on how you want to work. And let's take this, and I like to simplify things with data engineering. I think sometimes it gets overcomplicated. We have really three phases in data engineering. You have to ingest data, transform it, and then there's some consumption of that transformed data. The idea with ingestion is it's a one-to-one copy of the source. You're not applying transformations. You're ingesting the data as is. And then transformed is a broad category. This is any cleansing, conforming, modeling that you want to do of the data. But I think this helps break it down kind of in a simple way. And I wanted to just address one issue. I like to bring this up because I think I know it causes a lot of confusion. It's that this thing called the medallion architecture, where you see the bronze and silver and gold layers. This really isn't a meaningful architecture. These are data zones. These are different ways to group together data and then names assigned to them. It's not actually a logical architecture or a meaningful architecture where you're picking platform components and technologies and languages and formats. It's really a conceptual architecture, conceptual layer of zones. And it doesn't actually really matter what you call these zones. That's the key. It's that physical architecture that matters. So don't confuse data zones with data architectures. And I've seen this like over my career. I've seen probably every name possible for these data zones. So here's just a few of the common ones. You have like a landing or staging zone. You might have a raw or source or ODS zone, archive history, a curated, refined, or enriched zone, trusted or secure zone, semantic, maybe a sandbox exploration zone. And then I've even seen some customers, I guess, not bother with naming and just give them numbers. So L0, L1, L2. And truthfully, that is exactly the same as bronze, silver, gold. Like the names don't mean anything. Pick names that are relevant to you. But at simplest, what we're going to focus on is just raw and transformed. We're going to keep it really simple. So just don't confuse them. What really matters is the technologies that you pick, not how you name the zones. Now, double clicking a little bit, pipelines. So really, I thought I'd put together some slide that just defined what a pipeline is. I mean, really simply put, a pipeline takes one or more inputs that are data sets, um, does something to that data, and produces a resulting table. And so I like to keep it simple. They produce one table, and so each pipeline should produce a result set table, data set output. They can be built a number of different ways. So again, we're going to focus on one way to do it today, but there's different types of pipelines. So you've got ingestion pipelines or replication. Those are often very similar. That's about your ingestion. You have transformation pipelines and export pipelines. So those really correspond to those three zones I mentioned of data engineering. And each of those have slightly different patterns. That's why I think it's helpful to separate them. And there's different ways to define the logic in your pipelines. You can do that through SQL, the data frame API, Pandas API. You can do it through a visual graphical user interface, or now more and more we're seeing arrive on the scene the ability to define that logic through AI/ML models. So different ways to do that. And then there's different ways to deploy pipelines. So you can deploy them as a stored procedure, you can deploy them as a notebook, as a package or library, or if there's a third-party tool, it might be the mechanism to actually run and deploy the code. So again, there's so many ways to do data engineering, but we really want to focus in on the open pipelines. So what is an open pipeline? Well, it would be a pipeline built with open source tools or technologies. And that's what we're going to focus in on today. All right, so back to the overview. Here's what we're going to do. We're going to go through Openflow to ingest. And you can see the kind of the raw and transformed here. Then we're going to use dbt projects to transform. It's going to be stored in Iceberg, and we're going to query that with different flavors of Spark. And like I said, I'm going to just spend a few more minutes going through those various components in the diagram. So Openflow, this is a really exciting announcement. Snowflake is managing now and providing a managed instance of Apache NiFi with a bunch of enterprise capabilities built on top of the open source NiFi project. So if you're not familiar, Apache NiFi is an open source project that's been around for a little while now that provides a very efficient way to process files of data, and has a lot of connectors. And so I'll talk more about this, but this is Openflow is a Snowflake hosted and enterprise version of Apache NiFi. And it provides a lot of kind of key capabilities. With NiFi, you get a low-code visual interface to create your flows. Openflow provides on top of that a number of connectors, which are pre-built for really any of the sources that you have to ingest data from. NiFi operates at very low latencies, so you can easily handle streaming workflows. Openflow is all about it operationalizing and having an enterprise deployment of NiFi. So that's built in. Governance and monitoring and all of that is built in as well. So those are really kind of a quick flyby of the key features. And just to show you kind of a stack here of the architecture. So again, at the bottom, the base of this is Apache NiFi. The NiFi clusters themselves are deployed. You have a few options here, and I won't get into all the details, but essentially you can deploy it within Snowflake and container services, or you can deploy it in your own private network in your cloud provider as well. And so there's networking considerations here, access to your sources and all of that, but we provide two different ways so that you'll have whatever option you need to get access to your source and to manage it the way you want. And that's NiFi, running and operationalized. And then on top of NiFi, there's a number of components. So you have your standard NiFi uh, objects like processors and controller services and parameter contexts and all of that. And then Snowflake has built a bunch of connectors, which are predefined NiFi flows that allow you to connect to all of your source systems. And then on top of that, we have a control plane and a UI to help manage um, and then do observability and monitoring of it. So that's the stack. And then again, just to highlight that multiple deployment model, we support what we call bring your own compute, which is where you host the NiFi cluster in your own compute inside of your network, or SPCS data plane, where Snowflake does that. And then we have the control plane we mentioned in Snowflake that provides all of those management and administrative capabilities. All right, so that's the quick overview of NiFi. We'll see it in action here in a minute. Now let's talk about workspaces. So this is really exciting. Workspaces is a new advanced IDE, or integrated development environment within Snowflake, that really is going to become your one-stop shop for all editing and collaboration in Snowflake. So in the past, you've used worksheets in Snowsight, no doubt. And those can be SQL or Python. You've used notebooks. You've built other artifacts as well, and they've kind of each been a separate, experience and part of the Snowsite UI. With Workspaces, it's all going to be in one spot, and it's going to provide really one of the most important things here is just from the beginning, from the ground up, Git integration so that all of your files that you're working with, whether it's, and it can even be text files and configuration files, it can all be checked into source control, edited within Snowsite, and then you have the normal query running and visualization experience. So you can kind of see a quick screenshot there, and you'll see we'll be using this today, so you'll see it in action. But uh, I'm very excited about this. This has been a request from customers for a long time, especially with Git integration. How do I check my worksheet into a Git repo? And then notebooks as well. We provide that support today in Snowsite with notebooks, but with worksheets we haven't. So this is now the way to do going forward. All of these features will be in this one experience. It's based off of, if this is just showing kind of recapping a bit what I said there, but on the right, the diagram is showing kind of how it's built in Snowflake. So you have we introduced with notebooks the concept of a personal database. And so leveraging that personal database, these workspaces will live inside of that personal database. And so they're personal to you. And you can connect those, like I said, to a Git repo, or if you don't have Git, you can still use this capability. But because of Git integration, you're also able then to edit those files outside of Snowflake in your favorite IDE like VS Code or whatnot. So you have a lot of options here. And now you can collaborate between the two tools. And then we've built, the reason I'm going into workspaces is that we've built our DBT integration, kind of the editing part of it on workspaces. So very exciting. The third piece, DBT projects. Hopefully everybody watching this is familiar, has heard of DBT. It stands for data build tool. It's a incredibly powerful data transformation tool, open source tool. Very popular with Snowflake customers. In my opinion, it's one of the best data engineering tools out there. It provides this declarative data pipeline capability. And we have now support for running that DBT core, DBT open source tool directly in Snowflake. And this is really exciting. This is actually showing you a screenshot of the lineage view that we have of DBT projects. And if you've used, again, I'll show you this in action, but we provide all the core capabilities. So being able to run the models, test them, deploy them, schedule them within tasks in Snowflake, and then really exciting also to monitor them. We have a ton of observability features built into Snowflake in our integration now where you can see your DBT run history and all of that right in Snowsite. And I'll show this in action, but really exciting. I love DBT, and the fact now that you can run it in Snowflake is exciting. So, all right, and then the last piece before we get in the demo, I wanted to spend a minute on Iceberg and Open Catalog. So this is the third kind of really core piece of this of open pipelines is that the data that we produce is stored in an open format. And just to set the stage on where Iceberg fits, if some of you that are watching aren't familiar with open table formats like Iceberg, just to put this might help put it in context. So if you think about kind of the Snowflake platform, you think about an enterprise data platform, you have a lot of, let's start on the left, you've got a number of sources that you're working with. So in various formats and modes of kind of ingestion and latencies, that data gets ingested into your platform, and then you need to work with, you have a number of workloads on that data. So whether it's data engineering, advanced analytics, data science, building applications, collaborating, sharing the data, all those are different workloads. And then underpinning that, you need a platform that provides advanced governance, all the ease of use, simplicity, and DevOps developer lifecycle tooling. So all of that is the Snowflake platform. In the past, customers have stored their data and still continue to, in many cases, in Snowflake's native formats, where we actually store the data in our own storage accounts and provide all the security and governance for you and manage all of the operations with those and management of those data files and the data for you. And that's still available. But what Iceberg now allows you to do is we can have, in addition to that, those Snowflake native formats, you can store your data in Iceberg. And you can see the difference here. This is in a customer storage account. So this would be in your storage account. And There's two components we'll talk about briefly. There's the table format itself and the catalog. And so those are the two pieces. And that allows you then to still to work with that data from Snowflake, just like you would with the native format and apply all those same governance features. But then it allows you also to connect to it from other engines. And the one caution I'll add is when you connect from other engines to that data, you're taking on responsibility with Iceberg of managing that data yourself. You're responsible for controlling access to it from the various tools, table maintenance operations, and a bunch of other things that go along with it. So you just need to think through the use case that you have and make sure it makes sense. But this is where it fits in the picture. You can sort of choose to store your data in your own storage account in your own data lake and build a lake house with Snowflake as the data platform and query engine. And that's really powerful. Okay, so hopefully that helps you kind of orient. Really quickly, table formats. They're an evolution of storage formats in the cloud. There's been a lot over the years in data lakes. This is the most recent kind of iteration, but really they're designed to store the data and the metadata of the table efficiently in cloud storage. All that data gets grouped together, provides a lot of benefits. Like I said, there's been a lot of formats over the years. We've had with Hive Metastore as the primary catalog, but we've had lots of those formats. Provides really more advanced features. So it's lighter weight, better performance, provides transactional consistency, which was a challenge historically, and then advanced features like partition and schema evolution and time travel. So all this is provided by these table formats. You probably have seen some of these names, Iceberg, Delta, Hudi. These are the kind of popular open source table formats. There's three to choose from, but really at the end of the day, if you look at the industry as a whole and where it's gone, Iceberg, it's like the format wars that we've had over the years. Iceberg really has become adopted as the de facto standard here around table formats and being adopted by all the major vendors and the format that Snowflake has decided to back as well. So very important, the table format. The second part is the catalog. So there's really two components to this, like I mentioned. So the table format catalogs are used to keep track of which tables you have, and most importantly, to keep track of the current version of the tables and to provide the ability to atomically upgrade to the next version so that transactional consistency can be maintained. So it's really important. A lot of the features, we took what we had with the old file formats and Hive Metastore, and it's kind of been redivided so that a lot of that's in files on your cloud storage, but you still need the catalog to control some of these and provide governance and other capabilities. So it's still important. They're lighter weight and more interoperable than say Hive Metastore. There's now a standard Iceberg REST protocol, which makes interfacing with them very easy. And these are simplified. These are focused on Iceberg tables. These catalogs. So there's a bunch of them out there. I'm just listing kind of three of the popular ones: Polaris, Nessie, and Unity Catalog. And again, here, really the open source catalog that has become the de facto standard for Iceberg is Polaris, being adopted. Actually, a lot of the work from Nessie is being moved into Polaris. And this is the catalog that Snowflake is also actively contributing to in the community, just like we are with Iceberg. So that's the table formats. And Snowflake Open Catalog is a Snowflake hosted version of Polaris. And you can see that in the diagram here. So you can take Polaris since it's open source and you can run it yourself. But when you leverage Open Catalog, you're getting Snowflake managing that for you, providing upgrades, providing enterprise authentication methods, providing table maintenance, and a bunch of other features. So that's an important component of it. Like I said, for some customers, running it yourself is what they want to do, but for most, having Snowflake hosted is the best path. And Open Catalog provides, and Polaris provides some role-based access control, so it provides some basic governance capabilities, provides REST and management API interfaces and the rest and the other items. So that's the quick overview of Polaris. And then just to recap and put it in context, I just want to make sure, again, going back to kind of the beginning, Iceberg is important, of course, and as we're talking about open pipelines, this is an important part, but there's much more to think about than just as you are thinking about how to store the data, you take into account a lot of other factors. So Iceberg is one important piece, but when you look at Polaris and these open source catalogs, they're focused on providing support for table formats like Iceberg, but you have a ton of other objects in your data estate, in your enterprise platform that you have to manage and govern. So tables are obviously an important core piece, but there's lots of other things. There's all kinds of data products that customers are building, AI and ML models, stored procedures, notebooks, all kinds of other things you have to manage. And that's where you need an enterprise catalog like Horizon. So this is one piece, but make sure you keep in perspective how it fits in the larger ecosystem and the trade-offs involved. So hopefully that's helpful. This could be like a whole session, a deep dive on Iceberg and Polaris and all of that. But I also wanted to mention briefly, I wrote a blog trilogy on kind of catalogs. I think there's lots of confusion in this space, even today, about catalogs. And so there's kind of a three-part one. And I even ended with a nerdy Lord of the Rings reference around is it going to be one catalog to rule them all or not? And I have some thoughts there that I think are shaping up in the industry. So take a look if you're interested. There's more details on that. All right, but now it's time for a demo. So we're going to jump in and go through this. Again, I'll put this kind of overview slide up. We're going to go through and talk about, start with Openflow, go into DBT projects. We'll show how it's all in Iceberg with Open Catalog, and then we're going to query that data from Spark. All right, let's get into it. I'm super excited. I'm actually going to start the demo by looking at workspaces. So we'll kind of start with this component. So I can also show you that we have a clean demo. This is Snowflake Workspaces. And so it looks like an editor. Let me actually flip over and show you the worksheet experience, which you're probably familiar with. So if we look at worksheets, you've seen this before. You can browse your objects, you can edit and run queries, visualize them, have multiple tabs. Like this is the experience you're familiar with, but there's no Git integration here. It's a different experience if you're opening a notebook versus a worksheet. And so what we introduced is this concept, and you can see it here under projects. So on the left nav, if you go to projects and workspaces, you'll be able to see the workspaces. And this is super exciting, like I mentioned earlier. This allows you to, I've got a number of workspaces I can look and edit any files. So if I have a basic SQL query, of course, I can run that in Snowflake, no problem, and edit those. But I can also edit things like I could have text files. I can have JSON files in here, YAML files, whatever it is, I can edit them. They're all, if your workspace is backed by a Git repo, I can check them into source control. So you have kind of two modes here to work with. But really powerful way that I can tab-based experience all of that. You can have multiple workspaces. So at the top here, I've got this workspace. I can create a new one from a Git repo or from have it just be stored in Snowflake, the files. I've created this Summit demo that's actually backed by a Git repo. And I'll come back to that in a second. It's out here in GitHub, and I'll come back to this later. But my Git repo, you can now see I've got a changes option here up top where I can actually go in and see changes to my Git repo and all that. So native Git integration, that's the key. And let's open up a script I have down here. I can do my navigation. So I might be able to look at worksheets or the object explorer just like you would there. So you've kind of got everything all in one spot. And just to show you before I jump into the demo, we'll run a couple queries here. So I'm in the Summit demo database. And just to show you there's no objects or what objects are here. I do have 4 objects that are going to stay in the database, and these are the data kind of for the orders and transactions data I'll show you later. We're going to ingest that through Openflow, but I have those here as well. And I want to also point out just minor thing, but kind of a fun one, a recent announcement around our new pipe flow operator. This is exciting. You can see here the pipe flow operator. I'm actually able to chain queries together and access the results of one query in the next. So I'm able to, with $1, able to access the results of my show objects command. This is really powerful. You might have done this in the past by looking at the result scan of the last query and then querying that. but this is much easier. And it gets to be kind of Inception-like. You get, if you have, you can have multiple layers here, and the reference numbers are relative to your position. So you'll see in the documentation, they give you great examples, but very powerful. So we'll show you that. We'll also show you out in S3. I've got a bucket here, and I can refresh to show you there's no funny business, but there's this test table managed folder under here. So you'll see the summit demo will show up later. And then I've also got an open catalog. This is, again, is Snowflake hosted Polaris catalog. If you look at my catalogs here, I've got under the Snowflake external catalog, I have a summit demo catalog, but I've got no objects in it. Okay, so to show you that everything's empty and cleared out. Next, I'll introduce you to the NiFi experience. So when you get into NiFi, Openflow experience, this is the control plane. So you're able to do a number of things here. There's the deployments tab where you can create a deployment, and you can think about deployment as a connection to your Kubernetes, to like a container service, Kubernetes or container services in Snowflake. And we have those created already. I'm not going to go in this demo through how to create one, but we have a guide wizard to help you walk through whether you're doing it in container services or in your own network and your own cloud service. So we'll skip that part for now. And then a runtime is within a deployment, you can have multiple runtimes, and a runtime is a instance of NiFi. And so my runtime is set up here, and I have it open in this tab. Oops, no, I'll open it here. So this NiFi instance, let me sign in. This runtime is my instance of NiFi. And so now that I've opened this runtime, this is the NiFi editing experience that you're familiar with if you've used NiFi before. It's very powerful, GUI based, drag and drop. There's a lot of processors. There's over 400 processors or 389 processors in here. And this is growing all the time, that you can work with to do all kinds of operations, connect all your sources and ingest it into Snowflake. And then even do other things as well. We even support other use cases, whether that's reverse ETL or other integrations. So that's the NiFi experience. All right, so now that we've looked at the runtimes, let's go back. There's one other piece here in the control plane that's important, and those are the connectors. So if we look at the whole list here, we currently have 26 connectors, but this is changing daily. So we are constantly adding new connectors. And these are the ability to say these are predefined flows in NiFi that allow you to connect to your sources and ingest the data into Snowflake. And we're going to show in this demo the ability to connect to Kafka. And if you scroll down, there's a bunch of database connectors as well, which are super important. These are your CDC connectors to things like MySQL, Postgres, SQL Server, etc. And we announced also support coming very soon for Oracle. I'm able to add these to my runtime, so I can click on the Add to Runtime button and deploy it directly into my runtime. And I'll show you these in just a second, but this is the library of different connectors we have available that are, again, predefined flows. You can always build your own, but these are the predefined ones. So that's the overview of the control plane. Now let's actually jump in and look at these two connectors. I've got these two connectors deployed. They're turned off, and I want to go through just really quickly each of them. So one is going to be our Kafka connector. So this demo, I won't have time to go in and go deep dive into how NiFi works and how to do all this, but our documentation for each of these connectors makes this really clear. But the idea is once I deploy my connector, there's a number of parameters I need to configure. So by right-clicking on this, I can configure parameters. And those parameters then are all the things you need, like the connection, details, anything that we need to know specific to your environment. That's what you specify in the parameters. So that's how you configure the connector. And those are NiFi parameter contexts. So we'll have that defined. I'm actually going to start up before I can run the Kafka connector. Let's go back to our Snowflake script here. If you remember, I only have those 4 tables in here. I need to create for the Kafka connector, if I want to stream it to an Iceberg table, I need to create that table ahead of time, and that's in the documentation. So what I'm doing is creating an Iceberg table with my transactions that I'm going to get in there. And I've defined that as I've connected it to my catalog, which is Polaris. So I've created already the integration to Open Catalog. And then I've given it the other details here. So I'm able to write this, and let's update the permissions. And just to show you, there's nothing now in the transaction table since I just created it. You can see down here it says 0. All right, so we've got a table now. Now what we're going to do in NiFi is we're going to start up the connector. So there's a number of ways to do this in NiFi. I can, from the operator thing panel here, I can click start. I can also right click and hit start. But now we're starting up the connector. And if I double click on this is called a process group in NiFi. If I double click on this, I'm able to look at the whole flow. And you can see over here on the left, there's a navigation view. So I can see all the different components. There's even additional process groups, and you can drill into these. And then you'll see down at the bottom, there's this breadcrumbs. So I can navigate around. It's important to know about NiFi. So here I've got, this is running. Let's zoom in a little bit. You can see the consume from Kafka processor. If I refresh, you can see it's updating. So I'm getting data in. I've processed 119 files of data, 370 megabytes already. So this is running, and this will continue to run and process data at extremely low latency, providing a streaming use case for me. And then going back here, let's go do in there. Let's now do account star again. You can see I've got almost a million records in there. And if I look at some of the data, these are going to be the transaction data that we're going to look at later, but it provides an ID, customer, product, merchant, and some details about the amount and quantity and all that. Okay, so we've got streaming data flowing into Snowflake. That's really exciting. Now let's look at the CDC connector. So if I go back here, let's go back, and we'll leave this one running. The Postgres connector. So let's start this one up. Again, I've deployed this already through the method I showed you. I've gone in and updated the parameters, so it's ready to go, and I can start it. It actually won't do, and there's two components. So each connector is different. For the Snowflake, for the Postgres CDC connector, there's a snapshot load phase and an incremental load phase. So any replication tool, this is how they work. First time they do a full load, then after that they do incremental processing. And Snowflake is the same way. And so, or this connector is the same. So if I go into snapshot load, you'll see that I've got data here, or this is my predefined flow. Now, what I need to do though, in order for data to flow through, is I need to add some tables to it. So I have it saved here. What I'm gonna do is copy this. This is just a comma separated list of tables. And in my configuration here, let's go to the top level, and I right clicked and I'm gonna do parameters. In here, this is again part of the Postgres connector, has these parameters, and this is all documented. And there's an included table names field, and you can do it by a name or a regular expression. I'm able to add tables. So I'm just going to add 4 tables, and I could go in later and add a 5th or take one out. It's very flexible. So I'm going to add these 4, apply, and as soon as I apply, the connector is going to pick this up and start processing it. So if I go back to the processor group now, and I look at the snapshot load, if we get down lower here, you can see, let me zoom in a little bit for you. 4 rows now have flown through, and it's performing the snapshot load on those 4 tables. So that's what will happen initially. So that you can see immediately as I changed the configuration, it started running. That's going through. So now at this point, if I go back into Snowflake, the 4 tables I have are in a Postgres database in my container services in my Snowflake account, but it's connecting to Postgres. And now I can actually show these objects in this raw CDC table. And this was empty before. Now I've got 4 objects, and I'll just show you. I'll select some data from the merchants table. So this all came in from that CDC connector. Very powerful. And if I go back up to the top here in this one and show you the number of objects again now, Now we have 9 objects. So those 4 that I showed you originally, the streaming data table and the CDC tables. All right, pretty powerful, right? We showed you 2 connectors, Kafka for real-time streaming and Postgres CDC for database. And those are probably the most popular, couple connectors. So now what I want to do is show you, we'll just show that the Kafka streaming connector, I showed you I created an Iceberg table, but I want to show you that now out in Openflow. So here's Openflow again. Remember, this is managed Polaris. If I refresh here, you'll see that I have a raw streaming schema now, or namespace, and the transactions table. So this transactions table is an Iceberg table that is now available in Open Catalog. And I can also show you in S3 just to confirm that that actually has, we have a new folder here, Summit Demo, which has raw streaming and the transactions data. This is all Iceberg data stored out in your storage account. So there's the Iceberg piece for ingestion. All right. And in case you're wondering, for the CDC connector, that will support Iceberg very soon. It's not all hooked up yet, so you won't see that. I don't have that in this demo, but that'll be connected soon, and you can do the exact same thing with your tables from Postgres or from other CDC connectors. All right, now let's go back real quick. So we've done OpenFlow. We've actually even shown some of the Iceberg connectivity. We've done workspaces. Let's look at DBT projects. This is, again, one that I'm really excited about. So let's go back. In workspaces, let's just make things a little smaller here and get a little more space. I was showing you, we were working in a worksheet, a SQL worksheet. This is connected to my Git repo, and I actually have a DBT project already defined in here, and that's under Summit Demo DBT. This DBT project is a standard DBT core project. So there's nothing special here. This is in a repo, so you can take existing ones. You can run them in Snowflake. You'll see in my DBT project all the standard stuff. So I've got my DBT project YAML, and again, I can edit these right in the workspaces experience. I've set up some configuration for Iceberg here. I'm going to show you writing to Iceberg tables from DBT. So very, very cool. You can also open up, I have some profiles defined. So I'm only defining a dev database right now, but in the real world, you'd have different environments, dev, test, prod. With Snowflake, you don't have to define the account and username because it knows that from the context when you run it. So we have those pieces in here. And then just a standard project. I can have all the tests and whatnot. I've got some models defined here. So in this case, I'm doing a little lightweight dimensional model. So I've got a properties file, which specifies the source tables, those 4 that I showed you earlier. And then I've got I got corresponding to that, 3-dimension tables and a fact table. And it's basically reading from those tables and adding an unknown record and then storing it in Iceberg. So this is my Iceberg connection details, just like I specified on that streaming table that I created. So now I've got Iceberg tables here in the model. So this is my DBT model. Up at the top here, there is some DBT options. So you can see my project. I can have multiple DBT projects in the workspace, and I can toggle between them. I can specify different profiles. Like you saw, I only have dev, but if I had other ones, they would show up. And then I can do anything you can do on the DBT command line, whether that's compile or test or run or deps or whatever is available here. And you can see that here. So let's just do a compile. And when I run this, what we're going to do, and you'll see if let's move some stuff around here. Down below, I have, oops, give me a second. It's right here. The output. So this is actually running, this is so cool. This is actually running DBT inside of Snowflake. In the Snowflake warehouse that you specified, that's where it runs. So I know people ask that. It runs actually in that warehouse. In this case, it's an extra small warehouse. And I did a DBT compile, so you can see it's run and done that compile. Now, because I've done the compiling, I can do a lot of things. So if I've got my model open, I can view the compiled SQL. And this will show me side by side how, because in here I'm using the configurations, I'm using Jinja. And so all that now has been compiled down. I can look at that part. I can also show in the DAG. So this is really cool. I can actually view my DBT model visually, or the relationship of all my models visually. So I can see those here. And I'm able to, even as I'm in this view, if I want to flip and say I want to look at the fact transaction, I can click on the model, the node in the diagram, and it will open up the model here in the editor. So very powerful. This gives you the ability within, to navigate your models. Finally, I can deploy this model into Snowflake. So I can deploy this DBT project, and I'm going to give it the same name that I used before. I don't have that in here, but let's just deploy one. Deploy DBT project. We'll actually give it a name. So what I'm going to do, this is showing you everything I've done so far has been running inside of Snowflake, just in the workspace here directly. So directly from the workspace. But I actually can also deploy this as an actual object. And there's a new object in Snowflake called DBT project. So I'm able to come in to let's deploy this into my Summit demo and my transformed schema. And we'll create a new DBT project, and we're just going to call this one test DBT project and deploy. And what this is going to do, like I said, is actually create it's going to take all those files. You can think about it conceptually like kind of zipping them up, but it's going to create a object in Snowflake that has a content of those files at that point in time. One just super helpful tip for folks, if you're newer to Snowflake, one of the things I love about Snowflake is the ability to, with the query history, to reverse engineer things. So like as I ran that, when I'm learning things, my first question is, well, what did that do? Like, what did that actually do in Snowflake? And so if I come here to the query history, I can actually come in and I can see what ran. When I did that command just now, you can see that, and let's refresh here. Let's take this out. Look at all users. And their trick here is if you show client generated statements. All right, so you can see here that when I ran this command just a few minutes ago, I'm trying to see where it ran the create. Give me one second. List, here we go. So it actually ran this statement, create DBT project. This was the name I gave it, test DBT project, and then from the workspace path. And so this is really cool. So now I have an actual object in Snowflake DBT project, and this is really important as we get into DevOps and automation, which I'll talk about later. But you can see how I can kind of reverse engineer and see, now I can actually run this command myself without having to do it through the UI. So I can automate it. And that's really a core. I use that all the time as I'm learning new Snowflake features and thinking about the deployment and automation strategies. All right, so back here, now that the DBT project is here, let's just run it once. So I flipped it run. We'll click the run button. And now this is actually going to take, and it's going to run that actual model. And because these are Iceberg tables, it's actually going to create data in Iceberg, and we're going to see that show up in Open Catalog and all of that as well. So while we're doing that, this should just take a second to run. There we go. So it ran my 4 models. This is the normal DBT output you're familiar with. All right, so now if I come back, we've got a couple little windows going here. So let's bring this back down. And again, looking at the objects, now we have 13 rows. So we've got all those original objects, plus now in our transform schema, we've got these Iceberg tables. And if we scrolled over, you can see that the is Iceberg flag is yes for these. So these are Iceberg tables created from DBT. And again, if I go out to Open Catalog and refresh, we're going to see now in our transform schema, we've got these 4 objects. And we're going to see in S3 that we now have, let's go back up one. We now have the transform schema with our tables. So very powerful. I'm actually through dbt running in Snowflake, creating Iceberg tables in your data lake. So you can see how Snowflake is the lake house to do all of your data engineering. And we'll talk about querying here in a second. All right, so hopefully and then the last piece on dbt projects, you can schedule these as well. So once I have them created, I can actually, just like I can do with notebooks, anything else, I can create a schedule. All of this, what it's doing at the end of the day is creating a task and executing that dbt project. And so just like we looked at, um, you can see the project here, but just like we looked at earlier, I can go into the query history, I can see those commands, and then I can automate it. So I'm able to do that all. Um, I can figure out how the automation works. We also have in the monitoring area now a dbt projects option. And you'll see in a second, I'll run it from GitHub Actions, but I'm actually able to look at the run history. So let's go back here. All right, so that's the let's go back to our diagram. That is our dbt projects component. And we've shown the iceberg and player side. So last piece, let's go. Let's look at the different deploy or ways to consume this data now that it's in Iceberg in your data lake, how we can do that. So first thing is we can do right from Snowflake. And I have a real simple query here. If we look at objects in the transform schema, I've got those 4 Iceberg tables I created, our little dimensional model. Here's a query. So you can see how fast this is. I'm able to join together those tables. This is just really simple aggregation, looking at the total quantity and price by product category. And so you can see the output. And this is querying that data directly, in Iceberg, but through Snowflake. And this is the way then you can govern it and work with it like I talked about earlier. Now, suppose you want to connect from another tool. Let's show a couple options. So let's first show how to do this let's zoom in a little bit here so you can see better. All right, let's do one more time and then you can be able to. So here's a notebook, really simple. I'm running Spark locally. So what I can do is, let's make this for this part. All right. So I'm just getting the password. I'm configuring my Spark instance. So here, this is the standard configs that you use for connecting to Iceberg REST and using Iceberg in Spark. So I'm connecting to Open Catalog here directly. And to my Open Catalog instance I just showed you, and I'm passing it the credentials. And then I can do things like show the namespaces. Oops. So there's our 2 namespaces. I'm doing this through Spark SQL. And then let's do this one. I'm going to look at the transform. So there's our 4 tables that we had. And this is, again, this is not going through Snowflake at all. This is querying Open Catalog and then letting Spark securely access that data. And here's just one query to show you that same merchant table that I looked at earlier in Snowflake. We can query that from Spark, and you can see that here. So very powerful. So I'm doing this actually all from Spark, running locally. The other scenario that I wanted to show was you can connect also through other services. So let's go out here to Athena. And we're going to use Athena Spark. And so let's look here at our Notebook Explorer. So here's my Athena notebook. Let's zoom in one time here for you. And I've got this set up so that the same, I'll show you the comment here. Those same Spark configurations I've used to set as the session context in this notebook. So I'm just showing you here what I set, but it's the same ones. And now the same thing here again. Let's run this. So I can show our namespaces. There we go, same ones. So these are the same commands I had in the other notebook. But you can see now I'm connecting from Athena, running those same commands. There's our 4 tables. And then again, if I select from dim merchant, I am going to see those same records. So just showing you the interoperability. Now I'm able to query from various flavors of Spark and other tools. And there's other ones I could show here, but these are the two for this demo. You could query from Iceberg and other related tools. That anything that supports Iceberg REST, you can connect to this and work with. So very powerful, showing you that interoperability end to end. All right, so we've kind of gone through all of the stuff that I have on the slide here. I did want to show you really quick though, the ability to do this through DevOps. I know this is a question so this is kind of a bonus piece. I've got my project here defined, and I'm just actually going to go into GitHub Actions to do this deployment. And I'm just for now I'll kick this off. I'm not going to check anything into source control right now. This would usually run as part of a pipeline, but I'll just start it for now. And while this is running, let me show you what's happening. So if we go into our GitHub workflow definition, all right, let me zoom in again so you can see this better. So here's the code. So it goes through, sets up Python, installs. This is right now I'm installing a preview version of the Snowflake CLI tool that has DBT commands built in, but this will all be available in the normal public, PyPy distribution very soon. And this allows me to use the Snowflake CLI tool. This is not a DevOps session, so I didn't really go deep into this, but the Snowflake CLI tool is our core developer tool going forward that lets you, both as a developer doing kind of the inner loop work, but also in any automation deployment scenarios, you're going to leverage the Snowflake CLI tool heavily. So become familiar with it if you're not already. I've got it installed. And then what I'm doing is just a series of steps that are running the Snowflake CLI command. So I'm just doing my connection test. I'm doing a Snow DBT deploy. So I'm actually deploying all of the code that lives in I've checked out the repo. So it's in that folder, the source folder. I'm bundling it up, deploying it into Snowflake. And then I'm doing a list of the DBT projects in Snowflake, running a Snow DBT execute. So I'm actually running the models. Now, I'm doing a really basic one. I'm just deploying everything. You could, of course, target this to more specific sets of resources you wanted to deploy. And then I'm doing a DBT test. So DBT run and DBT test afterwards. So all these steps are being run together, and let's check it out here and see. Looks like that completed successfully. And so I'm able to you come in and look at the list. So I deployed it. You can see that it deployed the project, copied my files, deployed them, and then you can see the different list of all the projects deployed and the versions. I have those two, and then I ran it. And again, you'll see the standard DBT output, and then I did a test. And I don't have any tests defined, so it's just a kind of a placeholder, but if I had tests, they would run here. Pretty cool, right? So you can see this, hopefully this gives you enough to see how this would work and how you could connect this up with Snowflake. And then the last piece I'll show here back, now that we've run that deploy DBT project, if I come into the monitoring and I look at the DBT projects, you're going to see that this Summit Demo DBT project, which I deployed through GitHub Actions and ran, actually I have this now nice monitoring interface in Snowsight where I can see the projects, I can drill into it, I can see the deployed project, I can see that I did a test and a run, and then this part's really cool. On the run side, for that execution, I can actually, so we have the query profile, which you're probably familiar with in Snowflake. You can see the different phases of execution, but this section around query telemetry is very cool. I can actually see for my DBT execution, the tracing and the spans and how long in this case, each execution of each model took. So remember there was 4 models, so you can see how long each takes, and then how that makes up the whole amount. And you can drill into each of these and see details. So very powerful. This is what I mentioned about how we've integrated open telemetry into our DBT integration. And so all this is tied into our event tables and open telemetry. So from an operational point of view, this is very powerful and ties into that DevOps story. Okay. Whew. That was a lot. Uh, Hopefully you're excited. Like I showed here, we've seen all these. We built an open pipeline. We ingested end-to-end open pipeline. We ingested with Openflow. We transformed with dbt. Both phases, we'd store the data in Iceberg and used Open Catalog, and then we connected with various flavors of Spark to that data to surface it. Very cool. Hopefully you're excited. I hope you get in and start building these pipelines and love to hear what you're doing. All right, thanks.